Hello, I'm happy to present you REALEYES. Today we produce the world's only full parallax integral imaging or light field 3D displays, which are a standing picture, not a video. We produce them in Kiel and market them worldwide. Our customers are multinational corporations like Microsoft and Mercedes-Benz, advertising and media agencies, trade fair constructors, and advertising space marketers, as well as architects. Our images need as an input computer-generated 3D imaging. They are created individually for our customers, and they're exposed on the photomaterial. The objects can float up to 1 meter in front of the display and up to 2 meters behind the display. That is our sharp area. Behind the display, we can also go to unlimited depth. The size of our displays can be between 1 and 4 square meters. Our current markets are automotive and mainly advertising, and we now start to enter new markets like light design, arts, and entertainment. I'm a physicist and responsible for the technical stuff, and my partner, Felix von Laffert, is a lawyer and draws the threads. Founded in 2006, our first years were pure R&D, and until the setup of our own production in Kiel and the first market tests. Next year, we entered the market, and in 2013, we started an advertising space networks in cinemas, airports and shopping centers, and we started to introduce total quality management and continual improvement processes. Same year, we expanded our advertising space network and scaled our displays to a size up to 4 square meters. And today, we enter new markets and develop the next generation of 3D displays, as well as preparing for the digital light field displays. We have built up a strong network of high technology and research partners, like some Fraunhofer institutes and the University of Kiel, and leading edge industrial partners. Here you can see some pictures of our production in Kiel. Our production process is we get the lens plates that are injection molded after our design, and we put them together with aperture plates and install them on a structural sheet. And then after that, in the dark room, we attach a color microfilm to the backside of the images, and then the images are exposed with a imaging system. And so far for the content, we need a fully modeled, computer-generated 3D model. After the exposure, the photos go into the chemical baths like bleach developer and fixation baths, and then are put in specially designed light boxes. Why do we do light field technology? If you compare it to other technologies like lenticular printing, holography, stereoscopic cinema, or autostereoscopic 3D TV, there are some aspects that every media lacks of. Our light field technology can be seen without glasses. We do not depend on surrounding light conditions. Well, in the direct sunlight, you don't see much. We have a depth effect of 2 meters. We have vertical and horizontal parallax. We can use the full color spectrum. We have more than 100 different viewing angles. And as a vision, we will also do video images, but well, we'll see. The main reason for the light field technology is the naturality of the display. The correspondence between the accommodation of your eyes and the triangulation of the objects. For example, if you see a tennis ball 1 meter in front of you and you in the 3D cinema with glasses and you try to focus it, it gets unsharp because the sharpness of the tennis ball is still on the cinema screen some 10 meters away. And that gives you the exhausting effect or a kind of seasickness effect. Our current system uses for 1 square meter of an image some 16 gigapixels of image information. Those are divided to over 30,000 viewing angles per elemental lens. We have a field of view of plus minus 20 degrees in X and in Y. And our single lenses have a pitch of 2 millimeters, which also limits the size of the image carrier behind the lens pixels. Well, as said already, we have a sharp zone of 1 meter in front and 2 meters behind the display. Today, the scientific and the industrial world agree that the future of visible 3D display lie in the field of light field technology, and our vision is to do digitally once and after that with live content. On our point of view, the biggest challenge in that vision is the rendering, transportation, and the storing of large amounts of data, as well as the development of the suitable image carriers. For example, if you want to make the quality that we can show today as a standing picture with a video, you will have to face data rates of terabytes per second, or about 150 DVDs per second. When designing a display system, we have to make trade-offs between, well, 3 main factors. Those are the lens pitch, which is equal to the lens pixels, the 3D pixel size, and also limits the size of the image carrier behind each lens and the amount of information you can store on this image carrier size is of course also limited by the image carrier resolution. That amount of information is then spread over the full field of view angle and then gives you the depth sharpness that you can show. Another trade-off is the aperture size. If you make a diffraction limited multi-lens systems, you have an optimal aperture size. But if you want to have a bright display, you want to open the aperture further. And beyond that, you have to also care for the proper image carrier alignment to each lens in the micrometer scale and to have a homogeneous display over square meter sizes. So what are we heading for? Today, light field realized 3D displays already stand for joy and fun in the world of advertising, which is quite rare. What will it be when we can show moving pictures in the same quality? Well, I show you now a video which is taken during a Microsoft campaign which was present in our advertising network in over 35 places in cinemas, shopping centers in this video, and on airports as well. No. No. Where's the mouse? No.
It's better than 3D. It's the best 3D I've seen. It's just the way you can move around it and see behind objects. It's like it's actually there. It's just so clear.
Ich finde es gut, dass man keine Brille dazu braucht, dass man das so sehen kann.
Sehr interessant erstmal, zu gucken und das so alles so räumlich zu sehen. Das geht ja bis ganz verändert.
Yeah, it's new. Yeah, it's new.
Anything interesting?
And it's quite cool. It works. It's the future happening right there.
It just comes natural about lack of cold layers, the layers of the image. Yeah, it's really cool.
It's just so good. So good.
Thank you for your attention.